Hello students, how are you? I hope you have enjoyed my last lecture. This is Naren Kumar Dwivedi welcoming you all again in my next lecture covering two topics and numerical dealing. So let's begin with. So today we will be covering the first topic as Coulomb's law in vector form. So let's have first topic of today, and that's Coulomb's law. Coulomb's law in vector form. So as we studied earlier कि अगर हमारे पास में दो पॉइंट चार्जेस हैं और वो एक सर्टेन डिस्टेंस पे रखे हैं तो उनके बीच में फोर्स ऑफ अट्रैक्शन या रिपल्सन लगता है, तो सेम उसी स्टेटमेंट पे बेस्ड सपोज लेट वी हैव 2 पॉइंट चार्जेस Q1 and Q2 separated by a distance small r. So here we have 2 point charges. One is Q1 and next is Q2, and this is the separation between them, which is being called as small r. Now there are two possibilities of which we'll be talking about. The very first possibility is either Q1 into Q2 is greater than 0, else we can talk of second possibility could be or Q1 into Q2 less than 0. तो हम इस केस को सेपरेटली डील करेंगे, इस केस को सेपरेटली डील करेंगे। जैसा कि हमें मालूम है, अगर हमारे पास में ये जो प्रोडक्ट है Q1 Q2 इज ग्रेटर देन 0, कभी कभी ये सीबीएसई में और बाकी बोर्ड्स में क्वेश्चन पूछता है फॉर 1 मार्क, इफ Q1 डॉट Q2 इज ग्रेटर देन 0 और Q1 डॉट Q2 इज लेस देन 0, सो व्हाट पॉसिबिलिटीज आर देयर। तो हम इसकी पॉसिबिलिटीज की बात करें और इनके बीच में फोर्स क्या लग रहा होगा, अट्रैक्टिव फोर्स होगा, रिपेलिंग फोर्स होगा, इसके बारे में भी हम डिस्कस करते हैं। तो अगर हमारे पास में ये कंडीशन है, इट इम्प्लाइज बोथ Q1 and Q2 are either positive और नेगेटिव, और हम क्या बोल सकते हैं, दैट इज लाइक चार्जेस। तो हमारे पास में अगर ये दोनों का प्रोडक्ट Q1 डॉट Q2 ग्रेटर देन 0 है, तो हम बता सकते हैं कि वो या तो दोनों पॉजिटिव पॉजिटिव चार्जेस होंगे या दोनों नेगेटिव नेगेटिव चार्जेस होंगे, तभी इनका जो प्रोडक्ट है इट इज ग्रेटर देन 0। अब हम बात कर लेते हैं, हमें मालूम है कि जब लाइक चार्जेस होते हैं तो उनके बीच में जो फोर्स, कूलम्ब्स फोर्स लग रहा होता है, इट इज ऑलवेज रिपेलिंग। तो यहां पे हम फोर्स के बारे में प्रेडिक्शन दे सकते हैं, द फोर्स between them will be repelling अब हम सेकेंड पॉसिबिलिटी की बात कर लेते हैं। अगर हमारे पास में Q1 डॉट Q2 लेस देन 0 है तो हम क्या बोल सकते हैं, इट इम्प्लाइज both Q1 and Q2 are unlike charges। तो Q1 Q2 अनलाइक चार्जेस का मतलब क्या हुआ, अगर Q1 पॉजिटिव चार्ज हुआ तो Q2 हैज टू बी नेगेटिव, एंड इफ Q2 is positive then Q1 has to be negative, then only you can have their product as less than 0। और अनलाइक चार्जेस के बीच में हमें मालूम है फोर्स, कूलम्स फोर्स किस टाइप का लगता है, क्या नेचर होता है उसका, इट इज द फोर्स between them is attractive। तो ये तो कुछ ये दो केसेस के बारे में क्या क्या इन्फरेंसेस, क्या क्या रिजल्ट्स हम निकाल सकते हैं उनकी बात थी। अब हम कूलम्स लॉ को वेक्टर फॉर्म पे एक्सप्रेस करेंगे जब वो ये दोनों केसेस में ये 2 पॉइंट चार्जेस जो कि r डिस्टेंस पे रखे हैं इनके बीच में लग रहे होंगे, तो हम वो देखते हैं कि कूलम्स लॉ हमारा किस फॉर्म पे हमारे पास पे आएगा। तो सबसे पहला केस हम ये डिस्कस करते हैं। तो हमारे पास में जिसका मैथमेटिकल आगे डीलिंग करेंगे हम, वो कुछ इस तरीके से हमारे को मिलेगा। अब हम यहाँ पे इन दोनों के बीच में इस Q1 पे जब ये Q2 फोर्स अप्लाई कर रहा होगा तो ये फोर्स इधर की तरफ लग रहा होगा, जिसको हम लिखेंगे फोर्स ऑन 1/2 वेक्टर फॉर्म। Likewise, Q1 will also apply the force on Q2 and that will be directed like this, and this will be called force on 2/1. This is now the unit vector acting on Q1 towards Q2, that will be vector R12 cap, and here we can have, this is the vector R21 cap। So एक बार फिर देखते हैं हम, ये Q1 फोर्स है, ये Q1 पॉइंट चार्ज है, Q2 पॉइंट चार्ज है, ये डिस्टेंस स्मॉल r है दोनों के बीच का। जब ये इस डिस्टेंस पे रखे होंगे तो अकॉर्डिंग टू कूलम्स लॉ इनके बीच में फोर्स लग रहा होगा। अभी हम फर्स्ट केस के बारे में बात कर रहे हैं, Q1 Q2 ग्रेटर देन 0। तो ये हमें क्या रिजल्ट देता है, दोनों के दोनों क्या होंगे, लाइक चार्जेस होंगे, इधर पॉजिटिव और नेगेटिव, और लाइक चार्जेस में फोर्स रिपेलिंग होता है, इसलिए इस पे जो ये पॉइंट चार्ज फोर्स लगा रहा होगा, it is repelling force directed away from Q1 like vector F12, and in the same way Q1 will also apply a force of repulsion on Q2 that will be directed again away from Q2 along this F21. Now these are unit vectors along with direction being shown here. At Q1 the unit vector will be taken along Q2 and will be represented R12 cap, and at Q2 the unit vector will be directed towards Q1 and that will be labeled as R21 cap. Okay, now let's write the expression. The force on charge Q2 by Q1 is, how do we write? Vector force on charge Q2 by Q1 is F21. So we write it vector F21, which is equal to, is it clear? इसको how do we read? Force on 2 by 1 is given as 1 upon 4 pi epsilon naught. Now magnitude of, product of magnitude of both charges Q1 Q2 upon square of distance between them r square. Now the left hand side quantity is vector. If we just leave till here on right hand side, so it won't be a vector. Just to make it a vector, we need to multiply a physical quantity which is having magnitude 1, so that the magnitude may not change but may provide direction to this. अब इस राइट हैंड साइड को डायरेक्शन प्रोवाइड करने के लिए हमने एक यूनिट वेक्टर यूज किया. तो इस F1 की डायरेक्शन पे हमारे पास यूनिट वेक्टर है R12 कैप. तो हम यहाँ R12 कैप को मल्टीप्लाई कर देते हैं. इसी तरीके से हम सेकेंड फोर्स ऑन 1 by 2 लिख सकते हैं. सिमिलरली we can write force on Q1 by Q2 is F12. कैसे हम पढ़ेंगे इसको? फोर्स ऑन Q1 by Q2. तो ये हमारे पास में F12 फोर्स ऑन 1 by 2. तो अभी हम इसको क्या लिखेंगे? 1 upon 4 pi epsilon naught Q1 Q2 upon square of distance between them. And just to make right hand side a vector 1, we need to multiply a unit vector directed along F12. F12 की डायरेक्शन पे यूनिट वेक्टर क्या हमारे पास में? R21 कैप. तो हमने इसको लिखा R21 कैप. तो इस तरीके से हमारे पास में कूलम्स लॉ का ये वेक्टर फॉर्म है, जो कि हमने दोनों ही पॉइंट चार्जेस पे लगने वाले फोर्सेस को लिखा. अब से कि हमारे पास में कंडीशन आती है कि एक्सप्रेस दिस कूलम्स लॉ इन टर्म्स ऑफ पोजीशन वेक्टर्स. तो हम पोजीशन वेक्टर की टर्म पे इसको हम आगे कैसे लिख सकते हैं? तो यहां पे अगर हम इसको लिखें इन टर्म्स ऑफ पोजीशन वेक्टर्स, इन टर्म्स ऑफ पोजीशन वेक्टर्स हम इसमें लिख सकते हैं, ये वाला जो स्टेप है हमारा, वेक्टर F21 could be 1 upon 4 pi epsilon naught into Q1 Q2 upon R square into, how do we write this unit vector? Remember class 11th R12 cap. तो R12 कैप को हम कैसे लिखेंगे? वेक्टर R12 itself अपॉन मॉड्यूलस ऑफ वेक्टर R12, जिसको हम फर्दर क्या लिख सकते हैं? which could be 1 upon 4 pi epsilon naught Q1 Q2 अपॉन, ये इक्वल किसके होगा? स्मॉल आर के. और वो स्मॉल आर इस स्क्वायर के साथ मल्टीप्लाई होगा और ये दे देगा हमें आर क्यूब. और यहां पे वेक्टर रहेगा वेक्टर R12. तो इस R12 वेक्टर को हम फर्दर कैसे लिख सकते हैं? इसको हम आगे लिखेंगे 1 upon 4 pi epsilon naught Q1 Q2 upon R cube into this is vector R1 minus vector R2, where R1 is position vector of point charge Q1 and R2 is position vector of point charge Q2. तो ये हमारा इसी से इन टर्म एक्सप्रेशन हो गया कूलम्स लॉ का इन टर्म्स ऑफ पोजीशन वेक्टर्स ऑफ पॉइंट चार्जेस। अब हम आगे बात कर लेते हैं। सिमिलरली हम इसको भी लिख सकते हैं इसी तरीके से। यहाँ पे ये चीज क्या हो जाएगी, R21 वेक्टर अपॉन मैग्नीट्यूड ऑफ R21 जो कि R स्क्वायर के बराबर होगा और वो R क्यूब बन जाएगा। और R21 वेक्टर को हम क्या लिख रहे होंगे, R21 की जगह वेक्टर R2 माइनस वेक्टर R1। ओके, सो लेट्स टॉक ऑफ सेकेंड पॉसिबिलिटी। Second possibility was when Q1 dot Q2 is less than 0। तो जब हमारे पास में Q1 Q2 का प्रोडक्ट लेस देन 0 होता है, उस कंडीशन पे हमने क्या बताया कि ये दोनों के दोनों अनलाइक चार्जेस होंगे, फोर्स अट्रैक्शन लग रहा होगा। और अट्रैक्टिव फोर्स के केस में सपोज अगेन Q1 Q2 पॉइंट चार्ज kept at r distance apart, now force on 1 by 2 will be along this vector F12, force on 1 by 2 and force on 2 by 1 will be towards Q1. This is force on 2 by 1. So this is attractive in nature. तो हम यहाँ पे force on charge Q2 by Q1 is F21। अभी हमारा इस केस में F21 क्या हो जाएगा, 1/4 pi epsilon naught Q1 Q2 upon R square into F21 की डायरेक्शन पे हमारे पास यूनिट वेक्टर भी क्या है, R21। तो ये टर्म चेंज होगी यहाँ पे और इसको हम लिख रहे होंगे यूनिट वेक्टर R21 कैप। एंड सेकेंड केस में सिमिलरली फोर्स ऑन 1 by 2 F12 को हम क्या लिख रहे होंगे, 1/4 pi epsilon naught Q1 Q2 upon R square into what is the unit vector along F12? F12 की डायरेक्शन पे यूनिट वेक्टर हमारा है R12 कैप। तो इस तरीके से हमारे पास में ये वेक्टर फॉर्म आ जाएगा फॉर द सेकेंड केस। जब हम इसको यूनिट वेक्टर पे लिख रहे होंगे तो ये यूनिट वेक्टर हमारा यहाँ पे क्या हो जाएगा, R21 कैप, और ये यहाँ पे R21 का मॉड हो जाएगा। ठीक इसी तरीके से यहां पे हम क्या कर देंगे, इसको R21 और इसको हम क्या लिख रहे होंगे, वेक्टर R2 माइनस वेक्टर R1। तो इस तरीके से ये हमारा कूलम्स लॉ इन वेक्टर फॉर्म यहाँ पे कंप्लीट होता है। लेट्स मूव ऑन फॉर द नेक्स्ट टॉपिक, दैट्स सुपरपोजिशन प्रिंसिपल फॉर कूलम्स फोर्स और इलेक्ट्रिक फोर्स। तो हम बात करेंगे, अभी हमारा सेकेंड टॉपिक है। लेट मी मेक सम स्पेस फर्स्ट so that we can continue. Okay, I hope you all will be enjoying learning physics during this lockdown. It's very critical condition that our nation is facing, but the learning should not stop. This condition should not come across our learning. It must continue. So students, be prepared, focus on learning. Okay, so let's have superposition principle. Superposition principle for electric this is our next topic, superposition principle for electric force. Suppose for the statement, what do we do? What do we say? Statement: when multiple charges are interacting among themselves, then the total force acting on a particular charge is the vector sum of forces acting due to the presence of all other charges around it. So how do we express it? Suppose we have a point charge here as Q1, and we have our next charge situated right here, Q2, and next charge that we are taking is say Q3, and these all are positive charges, so let me put positive sign in front, and say we have next charge which is minus Q4, and the last charge that we are now having with us is minus Q5. Okay, so this Q2 is exerting force on Q1 as vector F12, force on 1 by 2 due to this Q2, presence of Q2, force acting on Q1 is directed along this and is F12 vector. Now similarly, force due to this Q3 presence of charge on Q1, it is directed along this. So let me put vector F13 labeling. Okay, so this is the force F13, force on 1 by the presence of charge Q3. Now due to this Q4 charge, now this is negative charge, this one is positive, so the force will be attractive and will be directed along this. So this is vector F14. Now we have force due to this minus Q5 charge on Q1, and again this will be an attractive force and will be directed towards this. So this is F15. So according to the principle is what? If multiple charges are interacting, then the total force on any charge, let's we have for now Q1 charge under consideration. So the total force acting on charge Q1 is the vector sum of all forces acting due to the individual charges present there. So this is vector F12 plus vector F13 plus vector F14 plus vector F15. So this is the superposition principle. Okay, so now under this topic, this much is sufficient enough. Okay, so let's have few numericals based on quantization as well as Coulomb's law. Now it's on problem solving session. So let's have numericals now. Let me just rub the board so that we can continue. Okay, fine. So here we have two questions with us. So the first question, I'm just reading it out. You just focus on. First question I'm taking from NCERT. If a body gives out 10 to 9 electrons every second, how much time is required to get a total charge of 1 Coulomb from it? So what is given for the first question solution? Given here, total charge with us. Total charge is 1 coulomb, and every second how many electrons the body gives out? Number of electrons being given per second is equal to 10 past 2 9 electrons. Now what is being asked? Then we need to tell how much time is required just to give or send out this much electrons every second just to make total charge 1 coulomb. So time is to be calculated. Okay, so now let's begin the solution part of this. So just to have this time, we must first have current with us, because charge is given and charge in time along with current, I equals to Q by T. So let's have this is the number of electron, and one electron carries charge, that we know, 1.6 into 10 past 2 minus 19 coulomb. So let's have charge sent every second due to the flow of this much electrons. So the charge given per second equal to number of electrons into charge on one electron, 1.6 into 10 past 2 minus 19. This is coulomb per second. Okay, fine. So this is 1.6 into 10 past 2 minus 10 coulomb per second. Okay, now we have with us this total charge per second, 1.6 into 10 past 2 minus 10 coulomb per second. Coulomb per second, it means this is what the current is. Else you can say electric current. Electric current. Now you can very well find out time. So time is equal to charge upon current. So charge is how much? 1 coulomb upon current is 1.6 into 10 past 2 minus 10. Okay, fine. So just after solving it, we'll be reaching at 6.25 into 10 past 2 9 second. Okay, let's convert this in years. So for the conversion of year, we need to convert this second into year. So for that, 6.25 into 10 past 2 9 divided by, in a year, 365 days, and in a day, 24 hours, and in 1 hour, 3600 seconds. So this much will be the value of year. So just after solving it, we'll be reaching at 198.2 years. So these many years will be the time just for 10 past 2 9 electrons being given per second just to make 1 coulomb charge. So this is the solution. I hope it's quite simple to understand. Let's have second question now with us. Okay, let me have space vacant first, so that we can have the next question solution with us. Now, for the second question, let's have question first. Two particles A and B having charges 8.0 into 10 past to minus 6. So what is given here? Given is particle A is having charge 8.0 into 10 past to minus 6 Coulomb, and particle B is having charge minus 2.0 into 10 past to minus 6 Coulomb respectively, are held fixed with a separation of 20 centimeter. Now the separation small r value is how much? 20 centimeter. Where should a third charged particle be placed so that it does not experience a net electric force? So between or close to these A and B, where the third charge, let's say C, be placed so that the C may not experience any net charge due to the presence of these two. This is the question that we are supposed to solve. Okay, so let's the solution part of this. So here, just for the diagram sake, this is say point A, particle A carrying charge 8 into 10 past to minus 6 Coulomb. Now the second charge is here somewhere, particle B, which carries charge minus 2 into 10 past to minus 6 Coulomb. Now the distance between them is 20 centimeter. Now here we must first make some concept that the third charge, net force given in the question, acting on the third charge which needs to be placed in this assembly of charges, so that that may not experience any resultant force due to the presence of these two. So this charge has got more magnitude than this one, and we know force is directly proportional to charge. So the force due to the presence of this will be more on the third charge, and this if we place the charge just here close to B, suppose this is point C where the third charge is kept, this one, and the distance that we are taking, it is say small d, that we are not aware. So here the force due to this will be directed away from this. Let me call it FCA. This will be more because this charge has got more magnitude than this one. Now just to balance that, this distance is small, so the force being applied by the presence of this charge at this will be more because it is inversely proportional to the distance. So this is the concept that we must learn, student. Force on B by A. Now given in the question that these two forces balance each other, I mean net force acting on C, resultant force is 0. So given magnitude of FCA is equal to magnitude of FBA. ये दोनों मैग्नीट्यूड फोर्स के बराबर होंगे, तभी वो कैंसिल कर रहे होंगे एक दूसरे को, और इस सी पे कोई भी चार्ज, कोई भी नेट रिजल्टेंट फोर्स नहीं लग रहा होगा, और हम यहाँ पे अज्यूम कर लेते हैं चार्ज स्मॉल q है. नाउ लेट्स हैव कूलम्स लॉ. तो हम इस FCA को अगर लिखें तो हम क्या लिख सकते हैं, 1/4 पाई एप्सिलॉन नॉट Q1 Q2, तो हमारे पास में जाएगा 8 into 10 पास टू माइनस 6 into Q upon distance square. Now what is the distance? 20 plus D. So this is 20 plus D square. Find this. This is Coulomb's law according to. Now it is equal to, now force on B by A. Oh no, it's wrong. It has to be force on C by B. Make the correction subsequently. FCB you must write. Okay, so how do we write it? 1 upon 4 pi epsilon naught. Charge here, magnitude of charge. Remember, don't write minus. 2 into 10 pass to minus 6 into second charge Q upon distance between them, that is D square. Fine with this? Okay. Now, what are the quantities that can be cancelled from both sides? This constant can be cancelled out. Now we can just eliminate this 10 pass to minus 6, 10 pass to minus 6 as well. Now we may just have cancellation of 2 with this 8 with this 2. It leaves 4 there. 2 4 the 8. Now just bring this physical quantity here and this there. So this is 4D square equal to 20 plus small d square. Now have the square root on both the sides. So here you have 2d which is equal to 20 plus small d. Now just transpose this d there so that you have d value as coming out to be 20 centimeter. This is our final answer. So I hope this is quite clear to you all. It's quite simple. So this way the third charge has to be kept at 20 centimeter from this B and at the side of B. Okay, so let's have third question now. Let me make some space again so that we can have the third question of the day. Okay, so the next question is, I'm just reading it out, you just listen. Charges. What are the charges? Let me write on the board first. Third question we are dealing with. So first charge Q1 is given as 5.0 into 10 pass to minus 7 Coulomb. Q2 charge is given as minus 2.5 into 10 pass to minus 7 Coulomb, and the third charge Q3 is given as 1.0 into 10 pass to minus 7 Coulomb, are held fixed at the three corners A, B and C of an equilateral triangle of side 5.0 centimeter. So the triangle is equilateral. Let me make that equilateral triangle now first. Equilateral triangle we are given, and each side of which is 5 centimeter long. So this is 5 centimeter, this is 5 centimeter, this is 5 centimeter, and equilateral triangle it is. So every angle has to be 60, 60, 60. That is clear to us. Now let we have leveling now. A, B. Let's begin with right here. This is A, this is B, and this one we call it C. Okay, fine. Now find the electric force on the charge at C due to the rest 2. तो हमें ये जो C है, यहाँ पे जो चार्ज है, उस पे ये दोनों की वजह से रिजल्टेंट फोर्स कैलकुलेट करना है. दिस इज द क्वेश्चन. तो हमारे पास में ये चार्जेस के मैग्नीट्यूड्स गिवन है और हमें यहाँ पे फोर्स निकालना है। तो ए पे हमारे पास 5 इंटू 10⁻⁻⁷ कूलम चार्ज है, बी पे हमारे पास -2.5 इंटू 10⁻⁻⁷ कूलम चार्ज है और सी पे हमें 1 into 10⁻⁻⁷ coulomb of charge is given in the question. Now let's have force at C due to this A. It will be a repelling force directed along this. Let me call it F on C by A, FCA. Comfortable with this? Okay. Now force at C due to this B. B is negative, this is positive, so the force will be attractive. So here the force will be directed along. So we write it now F force on C by B, FCB. Fine. So these two forces are acting along two consecutive sides of parallelogram. Remember that class 11th vectors, parallelogram law of vectors addition. So their resultant can be found by using parallelogram of vectors addition. So just parallel to that and parallel to that we must draw lines so that we can have resultant direction now. This will be directed along this. Okay, fine. Okay, so we'll be writing this FCA separately, FCB separately, and later we'll be applying parallelogram law of vectors addition. So let's write FCA, magnitude I'm writing. Okay, so FCA will be 1 upon 4 pi epsilon naught Q1. Q1 is what? 5 into 10⁻⁷ into Q2. What is Q2? 1 into 10⁻⁷ divided by distance square. Now what is the distance between these two? These two distance 5 centimeter. Let's convert it in meter SI unit by multiplying 10⁻⁻² square of this. Okay, so now this constant can be eliminated by its value as 9 into 10⁻⁹ into this is 5 into 10⁻⁻14, 7 upon this is square 25 into 10⁻⁻4. Now as you just go for the solution of it, you'll reach at 0.18 Newton. This is the force that you'll be getting after solution of this. I've solved it. Okay, now let's have second force, FCB. So we write now FCB equal to 1 upon 4 pi epsilon naught into charge magnitude 2.5 into 10⁻⁻⁷ into second charge 1 into 10⁻⁻⁷ upon distance square. Again distance is same, being that triangle being equilateral triangle. So 5 into 10⁻⁻² in meters square. Again you can do the same as we did for the FCA. So just after solving it you'll be getting 0.9 Newton. So these are two forces that we have calculated now. Now we can go for the resultant. So the resultant force on C we can write now. Resultant force on C. So that we are calling it FC, and that, what's the formula? Remember, that is F1 square. Now what is F1? It is FCA square plus F2, that is FCB square plus 2F1 into F2 into cos of angle between them. Now what is the angle between them? This is 60 plus 60, 120 angle. 120 degree it is. So cos 120 degree. So let's have values getting placed here back. So for the values you can have 0.18 square plus 0.09 square plus 2 into 0.18 into 0.09 into cos 120. So just after solving, you will be getting the final value as 0.16 Newton. I have just solved it. You can just check it, verify it using your calculation. You will surely get 0.16 Newton here. So this is the magnitude of resultant force. Now we can talk of direction. At what angle it will be inclined with this FCB. FCB के साथ में जो resultant force है, इस resultant force का हमारे पास में direction क्या आएगा? So the angle we can talk of the angle of FC with FCB. It will be tan inverse. What's the formula? Remember? Tan inverse FCA sin 120 upon FCB plus FCA cos 120. Okay, let's have values getting placed. So we can have now values with us. Tan inverse FCA. Now what is FCA? 0.18, 0.18 sin 120 upon FCB. FCB is what? 0.09 plus FCA again 0.18 into cos 120. So this now transforms to 90. So we have now with us 90 degree angle. At 90 degree angle, this FC will be inclined with this FCB. So I hope this is clear to you. This was magnitude and this is the direction with FCB. Let's have fourth question of today. So let me make some space first so that we can continue. So enjoying student perhaps. Okay. At the end of today's lecture, don't forget just to subscribe my channel so that you can continue watching my next lectures as well. I'll be covering your 12th syllabus completely in detail. Okay, so let's have next question. Fourth question is, a charge capital Q is to be divided into two objects. What should be the values of the charges on the objects so that the force between the objects can be maximum? So what is given? Fourth question. The charge Q has to be divided between two objects. So that the force between them is maximum. This is the condition given. Now let's go for the solution now. Solution part. Let the first object be given a charge small q. So what's the remaining charge now? Out of this q, we have just taken q, small q. So the remaining charge q minus q will be received by second object. Therefore, the second object receives the charge capital Q minus small q. Now let me assume that these two charges are placed at d distance apart. Let the objects be at distance small d. Now we can write the force between those two objects carrying charges q and q minus q kept at d distance using Coulomb's law. So the force, we can now write the force acting between the objects F equal to 1 upon 4 pi epsilon naught, constant of proportionality, into first charge Q, second charge Q minus Q, upon square of distance between them, that we have taken distance as d square. Okay, now this force has to be maximum. This is the condition given in the question, remember. Okay, so the force is proportional to this thing. So the force will be maximum if this numerator quantity is maximum. So we write now, for the force to be maximum, product q into q minus q has to be maximum. So this is the condition, students, you must remember. Okay, so for this to be maximum, what is the condition now? The first derivative with respect to this charge q has to be 0. So you can now write d by dq of q into q minus q has to be 0. This is the condition for maxima and minima. Okay, now after just having solution of this, you can write it q into q minus q square equal to 0 d by dq. Now just differentiate it with respect to small q. You'll have capital Q here minus 2q, that is equal to 0, or q equal to 2q, or this implies q upon 2 equal to small q. This is the final answer required. So students, this is the charge. It means total charge will be equally divided between those two objects. So I hope it's quite clear to you. Okay, let's have the last question of today. So the last question that we are having now with us is, let me make first space on the board so that we can have solution of the next question with us. Now, the last question, I'm just reading it out. You just listen. Two particles, each having a mass of 5 gram and charge 1 into 10 powers to minus 7 Coulomb, stay in limiting equilibrium on a horizontal table with a separation of 10 centimeter between them. The coefficient of friction between each particle and the table is the same find the value of this coefficient. Okay, so what is given information in the question? I'm just writing it out. Two particles, mass of both particles is given to be 5 gram. You can just have in kg 5 into 10 power to minus 3 kg. And charge carried by both particles, charge on both equal to 1 into 10 power to minus 7 Coulomb. Now the separation between them is given to be, separation is 10 centimeter. You can write it in 10 into 10 power to minus 2 meters. Okay, so let's these two particles at this much separation along horizontal, they are lying on the table and they are in limiting equilibrium. So during that limiting equilibrium, we must calculate the coefficient of friction acting between the particle and the top of the table. Okay, so this was the question now. So let's have the solution part of this. First, we'll have the Coulomb force calculation acting between those two particles carrying charge. This kept at this much separation. So the electric force, I'm just taking that force, electric force, as Fe, which is equal to, for that 1 upon 4 pi epsilon naught, I'm directly writing 9 into 10 power to 9 into first charge into second charge. As both charges are same, so the square will be taken upon the separation square. So I am having 10 power to minus 2, it is 10 power to minus 1, and square of this will be 10 power to minus 2. So just after solving it, you will be getting 0.009 Newton. I have solved it. You can just verify it after calculation. Okay, now let's talk of frictional force acting between the particle and the tabletop. So frictional force, I'm calling it small f, which is equals to mu into r, and r is equal to normal reaction, r is equal to mg. So this is mu into mass is 5 into 10 power to minus 3 into g is gravity, that's 9.8, has to be taken. Now the product is 0.049 mu. They are in limiting equilibrium condition. For the limiting equilibrium condition, F has to be equal to Fe. Now as per the condition of limiting equilibrium, F has to be equal to Fe. So we have 0.049 mu, which is equal to how much? 0.009, and here from you can write mu as equal to 0.009 upon 0.049. So this now comes out to be 0.18. So this is the required coefficient of friction between the surface of tabletop and the body. So that's the end of today's lecture, students. I hope you might have enjoyed. So don't forget just to like and share and just subscribe my channel so that you can continue watching my next upcoming lectures. Okay, thank you.